All right, we're still looking at functions. This is the second part of the lesson. So we just finished in the last video looking at how to determine what the domain and range of a function is. So I want you to take a moment and see if you can determine the domain and range of each one of these graphs here. Remember, for number 14, this is ordered pairs, so it may be handy to write the ordered pairs first, and then the domain would be your x's and the range would be your y's. This is a continuous line, so remember your x values go horizontally from left to right, and your y values go vertically from the bottom to the top. And then 16 is also a continuous graph, so it would go from the left to the right, and then from the lowest point to the highest point to find your range. And then see if you can answer number 17. Once you do that, come back and we will look at these together. Okay, let's see how you did with the self-assessment. These questions say find the domain and range of the function represented by the graph. Okay, for number 14, you can see that I took the ordered pairs, -2, 4, remember it's always x then y, and then -1, 2, 0, 0, 1, 2, and 2, 4. I wrote those as ordered pairs first. If you do that, it makes it very easy to pull the x's as your domain, the y values as your range. One thing I want to point out is you're always going to go from the smallest number to the largest with your domain and range, and you're not going to repeat numbers. So your range is 4, 2, 0, 2, 4. Because 2 and 4 repeat, I didn't put those twice, and I put them in order from lowest to greatest. So this is the correct way to write your range. It's not necessarily wrong if you write all the numbers and they're not in order, but this is the way you're going to see it most often, and this is the best way to represent your range. All right, for number 15, again, it has closed circles and it's a continuous line. You can see that your x's, that's your horizontal axis here, and this has a -1 and a 1 and a 1. So you can see that this would be -1/2, -1. This would be 1/2, 1, 1.5. And then if you go to the left, this would be -1/2 because this would be 1/2 and 1. So you have to be careful when you're looking at the scale so that you get the domain and range correct. So the domain here goes from -1/2, which is the same as -0.5. Here would be 1, so 1.5, 2, 2.5, and 2.5 again is the same as 2.5. So your domain is your x values from -1/2 to 2.5. The endpoints are included. So the less than or equal sign here represents that those points are solid and included in the domain. And then your range would be your vertical axis. So it's going to be the lowest point would be this point here, which would be at -1/2, which is the same as -0.5. And again, it goes by 1 up to 1.5, which is the same as 1.5. So your range is your y values from -0.5 to 1.5. Again, the endpoints are included, so we have less than or equal to symbols both here. Remember, if one of these is open, it would be a simple less than and not less than or equal to. All right, number 16, we look at the scale. This is 2, 4, 6, so that means this would be 1. So your x's go from 1 over to 5, so 1 to 5. So your domain is all your x's between 1 and 5. Your range goes from 0 up to 4. 4 is the highest point where you see a y value. So your range is 0 to 4. Your range is all your y's between 0 and 4. All right, so hopefully you got those correct. If not, we will continue to practice some. All right, so different words, same question. Which is different? Find both answers. All right, so it says find the range of the function represented by the table. Find the inputs of the function represented by the table. Find the x values of the function represented by -1, 7, 0, 5, 1, -1. Find the domain of the function represented by -17051, -1. So you can see those come from the table here. So it says, which is different? All right, if you look, this one says x value. The x value represents your domain. Inputs represent your x values and your domain. So the one that would be different here would be the range, right? The range is your y values, not your range is your outputs, your y values, not your inputs or x values. All right, so find the range of the function represented by the table. All right, so that's the first one, and then this one is represented by the table, where this one gives you your ordered pairs. So which is different? Find the range of the function is different than these others. All right, modeling real life. This says water pressure is 0 psi, pounds per square inch at sea level, and increases by about 0.44 psi for every foot an object descends in water. Does the situation represent a function? If so, identify the independent and dependent variables. And B part says a well dives from 1,000 feet to 3,500 feet. Find the domain and range. All right, so let's look at A part. Does the situation represent a function? If so, identify the independent and dependent variables. All right, so let's think back to what independent and dependent variable means. All right, so the variable that represents the input values or your x values of a function is the independent variable because it can be any value in the domain. The variable that represents the output or the y value of the function is the dependent variable because it depends on the value of the independent or the x that's plugged in. When an equation represents a function, the dependent variable is defined in terms of the independent variable. So you can see here at the top, this is kind of what this shows. It says that y is your dependent variable and x is your independent variable. So just think about that. So if I plug in 2, -2 plus 10 is 8. 8, the y value depended on what x I plug in. So if I plug in 0, 0 plus 10 is 10. Y would be 10 if x is 0. So y is going to depend on what the input is. All right, so does this situation represent a function, and identify the independent and dependent variable? Okay, so we're talking about water pressure at sea level, and we talk about that the amount of water pressure increases every foot an object descends in water. So we can conclude that for this situation, the water pressure depends on the depth of water because the water pressure changes with any change in depth, okay? Each input has exactly one output. So each number you plug in, each foot below sea level that you put in was going to give you a different output. So it does represent a function. All right, so it represents a function, and the water pressure would be the dependent variable, and it depends on the depth, okay? So the depth of the water is the independent. How deep it is would be your x. So you plug in how deep it is, and then you figure out what the water pressure is. So the water pressure depends on the depth. All right, so B part, a well dives from 1,000 to 3,500 feet. Find the domain and range. All right, this is going to be easiest if we just kind of look at this like an equation. So let's look at setting this up as equation. So we're going to have y equals 0.44x. And we already said that whatever x we plug in, that will determine the y value. So we need to find the water pressure from 1,000 feet to 3,500 feet. So let's put in 1,000 feet to begin with. So y equals 0.44 times 1,000. And then we also need to do 0.44 and 3,500 feet. All right. So our domain, okay, our domain comes from our x values. So we can see our x values are going to go from 1,000 to 3,500 feet. All right, so what is our range? Where our range comes from our x values. So we have to simplify this. So just take a calculator and we're going to do 0.44 times 1,000, and that gives you 440. And then we're going to do 0.44 times 3,500, and that gives you 1,540. All right, so again, the domain, that's from how far the well dives. And then the range, we had to input our x values into the function to figure out what the y value is to get the range. So y equals 440 when we plug in 1,000, and y equals 1,540 when we plug in 3,500. So just to recap, does this represent a function? Yes, it represents a function. And your independent variable is the depth of water, how deep the water is, and your dependent variable is the water pressure. Okay, the water pressure depends on how deep the water is. So questions A and B have both been answered. All right, example 5, using geometric formulas. Each geometric formula is a function. Identify the independent and dependent variables, then determine the domain and range for the set of all possible figures. So first we're going to look at the perimeter of a square. So P equals 4S, that's 4 times the side length. Your side length can be any length, okay? So as long as all the sides are the same length, it's a square. But the side length can be 2 inches, 3 inches, 5 feet, whatever. So S would be your independent variable. Side length is your independent variable. And P, the perimeter, depends on how long the side is. So S would be independent, P would be dependent, for example, 5. Then it says determine the domain and the range. So the domain here, the domain is your S, so it's going to be all S greater than or equal to 0 because you can't have a negative distance, and you're not going to have a perimeter or a square if you don't have anything greater than 0. So it has to be greater than 0, not greater than or equal to, just greater than 0. Your perimeter is your range, and it also has to be positive number, so it has to be greater than 0. So it can't be 0 and it cannot be a negative number. All right, B part says the sum of an interior angle measures of a polygon with n sides. All right, so remember, the sum of an interior angle measure depends on the number of sides, and a polygon can have 3 or more sides. So if you have just 2 sides, it's not going to be enclosed. You have to have at least 3 sides to have an enclosed figure, and therefore to be a polygon. So therefore, the sum of its interior angles measures will be a positive multiple of 180. So n would be your independent, the number of sides. That's your independent variable. S is your dependent variable. All right, so your domain would be multiples of 3. And your range would be multiples of 180. So 180, 360, 540, etc.